Okay. Hello, everyone. My name is Arvi, and today I'm here to talk to you about safety, security, and the best coding practices for your website. So let's just start off straight away. What is web security? It's there in the name. It's keeping your website and web applications safe on the internet and protected against any sort of malicious attack that may occur on your website. So why is this important? So let's just imagine this scenario. You've finished chat GPTing your website and it's time to put it out there on the internet. You need to think about how people are going to be using your website. Not everyone is nice and not everyone is going to be using it for the intention that you for whatever you intended it to be used for. And people are going to attack it and people are going to they're going to try and harm your website in any possible way. And we need to make sure that the data that we store is safe, and both our own and the user data. So, and we also need to make sure that we keep our websites running for the long run. So if in case like our website breaks down as soon as like we put it out there, it gives us a very bad reputation. And in any company, if like a breach occurs, there's like a loss of trust, loss of money, and like a loss of reputation. And this may not seem like a big deal for like small websites or small projects that you're building right now, but you guys have to remember that the ops are always out there. So let's lock in and like let's start straight away. Let's go through with this course, assuming that you know nothing about safety and security, and we'll hopefully come out of this code with some sort of confidence in our code and some sort of our code will hopefully come out able to guard against some of the most common attacks that we face on the internet. Whatever code that I will be using, I'll share it with you in the link of this chat. So just go through it once at the end of the session if you have any doubts about it. So let's go. Let's start off with what are the most common attacks that we face. There's I've listed them out on the screen, as you can see. There's cross-site scripting, cross-site forgery, SQL injection, and people are really creative with all of this stuff, but hope we'll outsmart them today. And let's just get in with cross-site scripting. So what is this? This is basically when attackers try to inject code into your website, any sort of malicious code into your website. And how do they do this? So let's assume that we have like a social media app and we're allowing users to create a profile and they can, add in whatever information that they want. We have no checks on what they want to add. So they can create like a login and their user and their bio. And now let's suppose that we have someone who has like bad intent and he inputs a JavaScript code into his bio, which could do something as harmless as maybe change the color of the page when you visit his bio and or like when you visit his profile. Or it could do something malicious like downloading software into your program that could steal your cookies or like your information. And obviously you don't want that. Um, and something similar actually happened to a popular social media app called MySpace, which I think was around 2000s. It was quite popular. And a user had inputted a JavaScript code into his bio, which every time somebody visited his profile, it would send a message to all of his friends of all of the profiles that he's visited. And this really, like, obviously it's really bad and it caused a lot of like loss of trust in MySpace. And we want to protect against that. We want to make sure that this doesn't happen. Another way that like cross-site scripting could happen is if you inject like the code into a URL. So like if you click on a link, the code can run and it can again run code on your computer, which can steal things and just harm you. And so like how would we protect against this? So the first thing that we have is input validation. Input is basically what you're getting from your user, and validation is putting checks on it and making sure that the input follows these checks. An example of no input validation would be like if you're getting like login, just checking, okay, they've logged in, their password and their username match, we'll just let them in. Or like it could be just like, okay, they can put whatever they want onto their profiles or their bios or whatever. So we don't want that. We want to make sure that we check what kind of input they're putting into our computer. So we want to check if like we want to put like checks on like has to be a string, this has to be an integer, or we can put in things like we don't want to allow like HTML tags, so we don't allow like any sort of characters that we don't like. Or we can put in checks like we need this to be just 100 characters long or like 100 words long or whatever. We put all these checks so we know what kind of input we are getting and what kind of so before it's even like processed, we know what kind of input we're getting, and we don't want to like waste our time with like unnecessary input. So this is quite important. The next thing that we have is output encoding. So we get input and we give it out, like we display it to other users. Like for example, we get profile input like bio input and we display it to other users. So output encoding is essentially we're making sure that whatever output we're putting out there is not, we tell the browser that this is just data, it is not code. We don't want the output to be run as code. We just want it to be data. We are making sure that we tell our browser what exactly we're putting out there. So I'll show you an example of how we can output encode. Um, let me just, yeah. So over here, in our, one second, output encode. Yeah. So over here we have like a very simple flask app. And over here, this character over here tells it that whatever input that we're getting, this user input that we're getting, it tells it that this is just input. It is just data. Do not take it as do not run this code. This is a JavaScript code. It says do not run it. So when we run this, the output that it'll just show this code. And if we run it without this escape character, it'll show, it will give an alert saying we've been hacked. So just make sure that when you're inputting any sort of when you're putting out any information that a user has inputted, make sure that you check first that it's valid input, and secondly check that this input is provided simply as data. Okay, let's get back to what we were let's get back to the other ways that we can prevent this. The way that we can prevent this is using secure headers. So what is a header? A header is where you can provide extra information about your request. So like whatever, if you're logging in, it can provide information about like your authorization information, or like what kind of inputs that you want, like the format of your input and your output. And so HTTP headers give browsers instructions on how the page should be rendered. So so make sure when you're giving this, always use a secure protocol like HTTPS that encrypts your data. And so this way that like when you're whatever information that you're sending, it cannot be stolen. So make sure that you use like a secure protocol that encrypts your data. And you can also, another way that you can do this is you can tell your browser which sites and sources you consider trustworthy. So, and this is done through a header called Content Security Policy. So it's CSP for short. And this basically tells your browser which resources you can load onto your page. So it prevents cross-site scripting attacks by only accepting content from sources that you trust. Okay, so a way that you can input this is basically um, you can configure this into your you can configure this into your code by just putting it into the meta tag over here. Like you can say we want content security policy as the header, and can just configure it into your HTML code. So uh, this is how you do it. Okay, and then another good practice that we have when we are uh, writing any sort of code is to avoid inline JavaScript code. Inline JavaScript code is basically code that you put inside like your HTML pages. So when you go to like any sort of page and you can like inspect the page, right? So you can see all sort of code that is coming there. So it's always good to keep your JavaScript in a separate file so that attackers don't know what exactly, like it adds a layer of security. So you always keep it in a separate file so it doesn't become like easy to manipulate your data. Okay. Let's go on to the next kind of attack that we have, which is CSRF. So this stands for cross-site request forgery. So this is like when somebody tricks you into revealing data that you don't want to reveal, obviously. So let's assume that you've logged into a website that you trust. Like, for example, a bank website. Okay, you trust it, you trust that they're going to store your information securely, and like, you trust them to not do anything wrong with you. And then you've logged into a session over there in your bank website, and you open a tab in another browser or open another tab in your browser, which could be a malicious site. So this site can send a request to your bank website. So from another tab, it can send an automatic request to your bank website or any sort of website that you trust. And your session is already logged in over there. So that website just thinks, okay, fine, they're sending me a request, but it's actually somebody else. So we need to make sure like it's unknowing. It doesn't happen with like the user doesn't know this is happening. It just sends a request, and obviously like money could be transferred, or like any sort of process could be initiated that's not under your control. And there have been a lot of like Bitcoin scams that have happened because of this. Like a malicious website has like hijacked the user's sessions and like stolen data or manipulated transactions. And obviously, as like a backend developer, how we can protect against this is the first thing that we can do is using anti-CSRF tokens. So what this is you can generate a unique token when a user logs in. So like when a user logs in, you generate a unique token and you send it to the browser and say that, okay, fine, this is the user's token. And anytime the user makes like a request that could like alter their account, like transfer money or like any sort of thing that could like alter their account, the browser will send back the token. So if another browser is initiating this request, they won't obviously have the token. So we can know that this is not our browser that is sending this request, and we don't allow it. So we match the token whenever like you send a request, you match the token with the anti whatever token that you sent to them, you match it, and then you check if it's right. And this is how we prevent like other browsers from sending us requests. Another thing that we can do is called same site cookies. So by default, when so by default, a browser, it sends the cookies back to wherever the request is originated from. So if another browser requests something, the cookies are automatically sent back to them. And malicious website could like trick users into like sending cookies for like to a legitimate site by yeah, they could trick them. So same site cookies, it tells the browser which cookies they can send and what they cannot. There are two modes that work in this. One is strict and one is lax. Strict is when the cookies are only sent to the site that has issued them. So if I issue a cookie, only I can get the cookie back. So if I follow URL to another page, they won't get any of the cookies that I've issued. So this is a strict thing. And lax is where like it's sent in like normal browsing requests. Like if you follow a link to another page, it's sent. But if that page requests something malicious, like maybe an update or something like that, then it's not sent. So this is quite useful when we're trying to prevent CSRF attacks because it tells us what to accept and what we're not accepting. Okay. The next thing that we can do is a referrer header, which is similar to CSP. It just tells the browser which are the trusted sources and which you can like what you can like where you can send information, who do you trust. You can configure all of that into your site. And the last thing that we can do is a confirmation, a transaction confirmation. This is basically like asking the user to confirm and authenticate that they've like done this. Like, okay, hey buddy, I'm transferring money. Did you send this request? So anytime you're doing something that's like you know you could say like that could like change an account, you can be like, are you sure you want to do this? So it's just confirming that you want to do this. So I'll just show you one like example of how to use an anti-CSRF token. So just one second. Yeah. So over here I have like again a Flask app. So this is over here, you put like a secret key. So this you can generate, and you can put up a secret key over here. And over here, you generate a token for every session that they do in, and you store the token in the session. Basically, you, like tell the browser that this is the token that I've generated. And anytime like anything, like you're transferring something, you get the CSRF token back from the browser. And if it's not valid, you say that it's an invalid. 403 basically stands for a forbidden. So it's the status code. It's saying this transaction is forbidden. If it matches, we can transfer. So this is how we can configure a CSRF token into our website. And this is a good practice when you're trying to do any sort of when you try to make any sort of website. So let's get back to our PPT. And over here, so the next kind of attack that we have is an SQL injection. So what we just talked about was, when we talked about cross-site scripting, that was a code injection because we're injecting code into our website. So SQL injection, I'm sure you can guess, is injecting SQL into our website. So how this works is okay, let's take an example of our uh, social media app again. So suppose we are logging in and the user inputs like a username like admin dash dash. So when we're executing this, when we execute a statement to the database, when we're trying to like log a user in, we basically say select user from the database where the username is this and the password is this. But when they input something like admin dash dash, dash dash in SQL basically says ignore the rest of the statement. So they're ignoring the password. So they say select user where username is equal to admin dash dash and ignore the rest of the statement. So basically the user can get into your website as an admin and they can steal your information. They can alter your website, whatever. This is obviously very dangerous and risky. And so again, how do we protect against this? What we do, since it's similar, it's also an injection attack. We have to make sure that we validate our input. We can tell the user this character is not allowed, dash is not allowed, only underscores are allowed, and all of that. So we are validating our input. The next thing that we can do is parameterized queries. A parameterized query is basically when you say that you define the SQL statement beforehand. So you say that this is the SQL statement, and whatever data that you're getting from the user, like the username, you take it only as data. You don't take it as um, you take it only as data, and you don't take it as whatever like executing the data that you're getting. You have to make sure that it's only data. And the third thing that we can do is ORM. So what is an ORM? It is basically an object relational mapper. This is when you don't want to worry about so ORMs are used when you don't want to worry about databases and how you store them and how you query them and all of that. And we just when we don't really want to worry about that much about databases and we only want to worry about our code. So we basically write code in like a programming language that we're comfortable in, like Python or like Java or anything. And we write code and we don't worry about the SQL. We don't worry about the querying part of it. So this is useful when we're preventing attacks because it automatically does the parameterization. So I'll just show you an example. Yeah. So over here, I'll show you first, I'll go through the entire thing. So first, this is a raw SQL statement where we say select star from user where the ID is user ID. So this is unsafe because we don't know what they're going to input and anything. So we don't want to put it just like this because this will take it as code. It's just inputting whatever the user is taking. We're just inputting it over here. The next one that I talked about is parameterized, where we are saying select from the user where the ID is this. So the query is defined. It's already defined, and whatever we're getting, we're executing it as data. So we're over here, we're saying this query is defined, and this whatever we're getting over here, it's data, and we're executing it based on that. So I'll just show you. I mean, okay, I don't think it works. Okay, and this is an ORM. So basically, this over here, this is a Python concept, right? Classes are Python concepts. You're defining the table using a class. So we're saying this has to be integer string. You're validating. You're validating the input that you're getting as an integer string, etc. And over here, we're using SQL Alchemy, which is a popular ORM that is used everywhere. And we're creating an engine and we're binding it to this. So this is basically like binding the ORM to your code. And over here, so we're getting the user ID that we're getting from the user. This is one. And it's querying based on the we can say that user, if the user ID is this, get me whatever user you have. So this automatically does parameterization and input validation. So this is quite useful when you're making code. You can input it into your code. And the last thing that we can do when we're talking about SQL injection is we set accurate permissions. So we can say a user if for example we're talking about like a blog website or something, a user's only allowed to view other people's blogs. So they're not allowed to update, they're not allowed to create, delete other people's blogs. So we set accurate permissions. We say that, okay, we set like an explicit permission saying that they can only read other people's blogs. So this prevents like any sort of like another user trying to change anything because they can only view it. So we're setting the correct permissions for everything. So this is how we prevent against SQL injections. The next kind of attack that we have is DOS, which stands for denial of service. And I'll explain this using an analogy. Suppose we have a stall, like a stall that we're selling something, maybe like cupcakes or something, and somebody who doesn't like you, they send in like an entire mob of people. They send in so many people, all of them are asking for your cupcakes, and and they don't actually want it. But people who actually want it are not going to come to your website, are not allowed to even access your website because there's so many people around you. So this happens with our website when an attacker sends in like a lot of malicious requests to your server to like overload it. And they send like junk requests to like a lot of like login requests or anything to overload your server and prevent people who actually want to access your server from getting to your thing. So how do we prevent against this? The first thing that we can do is limit requests. This basically means that like set uh, a reasonable limit on how many requests a user can send from an IP address, or like how many requests they can send within a time frame. So if a lot of requests are coming in, we say that we're not allowing this. You're limiting the number of requests. So uh, I'll show you how you can do this. 1 second. Yeah. Uh, Sorry. So over here, we set max requests per minute 100. So user can send only 100 requests in a minute. More than that, and they're not allowed. They're stopped. And so we this is basically we're tracking the number of requests that they sent in the last minute, and then we basically just say that a rate limit has exceeded, and you don't allow them to proceed any further. So you can input this in, I mean, you can configure this into your website. The next thing that we can do is called, okay, the next thing that we can do is prioritize our requests. So basically, if like your application handles a lot of different requests, we can prioritize which tasks are critical and that won't fail if another task is failing. So make sure that like the essential functionalities remain available in case of any sort of attack. The next thing that we have is load balancing, which I will cover more into detail later, but I'll just give you the basic concept right now. It's basically um, if your website is getting a lot of requests, you can balance the load by allowing multiple servers. So basically, if your website gets like 100 requests, you can send 50 to one server, 50 to another server, or like basically divide your servers to balance the load. And web application firewalls, also I'll explain more into detail, but imagine this as like a security guard who's like looking at who is sending what, and like filtering and blocking and just um lo- observing your traffic, whatever traffic that you're getting in your websites, just observing it and allowing people based on who he thinks is right and like who he thinks has good intentions. So the next thing that we next kind of not it's not really an attack, but the next kind of thing that we need to secure against is broken authentication or broken authorization. The difference between authentication and authorization, I'll like okay, authentication, like suppose in your house the people who are allowed into your house are you, your parents, your siblings, maybe your grandmother. So we know we're like setting who is allowed and like who is a user of our website. So we know who is like a user. So that is authentication. And authorization is basically like in your house. Suppose you can't go, like you don't have the key to your parents' office. You're not allowed over there. So your authorization is setting who is allowed to do what. Broken authentication is when somebody maybe like steals your password or like logs into your account without you knowing, and like just like guessing like stealing your information, guessing your by guessing your password and all of that. And broken authorization is like when a user like maybe like manipulates a URL to get access to something that he's not supposed to get access to, or like when like a client when we're creating a website, if we only set like client side permissions that like only like uh it's not good practice to set only permissions on the client side. We need to make sure that we set permissions on the back end as well. So how we prevent against this is any information that we're getting that is sensitive and like that's supposed to be secure, we need to encrypt it or hash it. Like for example, um a password. We never want to store the password in our database without any sort of encryption. If we just store a password as it is, if in some sort of way a user is able to access or like access like a person's like username and password, we don't want to send the password back as like whatever it was. We want to be able to hash it using like secure algorithms like bcrypt or something. And so whatever data that we're storing, we store it encrypted into the database. So always make sure that anything that you store is that's sensitive and that's important, encrypt it and store it into your database, which helps like the users in case anyone tries to like steal their passwords. The next thing that we can do is session management. So basically, after a user logs in, you generate a secure session for them and ensure that these sessions expire and can be invalidated within like a given time frame or whenever it's needed. So this is useful. Like suppose if you leave your laptop somewhere and after like 10 minutes or like 20 minutes, somebody comes in and tries to like tries to like use your account to get your information or whatever, you need to make sure that this session has expired. So you make sure that you know when you set like the correct time limits for your website to expire tokens and show when the session is expired. So make sure that that is secure. The next thing that we have is password policies. So, when you're logging into a website and they say that your password has to be like 8 characters long, it has to have like an uppercase, lowercase. These are password policies where we're trying to help out the user to set a secure password. Like make sure that you don't accept weak passwords. You want them to be able to set strong and secure passwords. Like, like so like VTOP and all says that you can't have like a previous password and everything. They have strong password policies that you to make sure that like nobody gets into your account. I'll show you an example. uh okay, yeah. Okay, so over here in this thing, we are when the user is creating, we say that uh this is their sign up and everything. When we're storing it, we store the password as like we create like access tokens over here for their session management. Whenever they're when we verify their password, we store like access we create access tokens. Access tokens are basically they're telling you how long your website can be accessed for, like how long the log whatever you've logged in, how long it's valid for. Okay, so um this is how you can do session management. And over here, one second. Yeah, so over here in Fast API and Flask, most of the programming languages that we get when we are storing a password, they automatically hash it. Some places you can explicitly define it, but most of them automatically hash it. So even this get password, it's basically decrypting the password before it gets it. So this is how we can do like authorization and authentication. And how we protect against broken authorization is we have role-based access control. This means it's basically in the name, based on your role, you know what to access. So if you're an admin, you can access everything. If you're a user, you can access this. So set proper permissions and conditions for everything that you're allowing. So if you have something where you don't want anyone to create or delete or anything like that, make sure that you set proper permissions, like explicitly state that this is only allowed for admins, this is only allowed for users, so that the backend can check it when it's happening. And you don't want so that and like nothing, no URL is not is accessed like unknowingly. Somebody can't like manipulate a URL to get something that they don't want. Make sure that you set a proper permission for everything that you do. Okay, now we'll get on to, since we are Google Developer Student Club, I will be talking to you about how we can use some of Google's products to maximize security. And so the first thing that we can use is a key management system. So this is provided by Google Cloud, and it's a service that allows you to securely manage keys for any of your cloud resources. Encryption keys are basically like secret codes that like scramble your data and into like an unreadable format. And decryption keys are basically like it's a matching thing that allows you to unlock this scrambled data. So if you want to like store, manage, delete any of these keys, we can use this key management system. The next thing that we have is Cloud Armor, which is a web application firewall, and it's also a DOS protection service that's offered by Google Cloud. So it just acts like a security shield in front of you and your client and your server. It acts like a shield between any sort of request that you're getting. The next thing that we have is virtual private cloud. So this is basically, it allows you to have a private network for you inside the internet. So the internet is really big, it's really vast, it has a lot of resources. And there are some resources that you want only you or your company to be able to access, right? So you want to have safe and private, if you want to have like a safe and private network where you can set permissions that, okay, only my friends can access this resource, you can use this virtual private cloud. It's basically a private network for you inside the internet. The next thing that we have is identity and access management. Um, this basically lets you control who can access what and what actions they can perform. It's basically, again, for the permissions, setting permissions. It basically lets you define what actions are allowed to be performed by whom. Okay, so identity and access. What is your identity and what are you allowed to access? It's helping you manage that. The next thing that we have is Firebase authentication. So this helps developers add user authentication features into the like mobile and web applications, and like signing in, signing out, logging, registering. It helps you manage all of that, and it like simplifies the development process. And the good thing about it is it has all of the safety methods that we've been talking about till now, like input validation, hashing, all of this it has built into it. So you can use it if you want to create like a secure authentication. You can use Firebase authentication for your websites and whatever web apps that you build. Okay. The next thing that we have is a Firebase real-time database. So this is basically a NoSQL database, and whenever you change anything, it reflects immediately across all of the connected devices. So like if you change anything on your database, your mobile computer, all of it changes real time. Okay. So the way that you can keep this database secure is you can have rule definition. So you define the security rules that you want within your database. So like if you want like uh, validation, like it's like how it's structured, like you want integer strings, you can have that validation. You can do role-based access control. Again, you can decide who accesses what. You can have all of these conditions. And another thing that makes it secure is it's integrated, like it's the authorization is integrated with the other Firebase services that are provided. So like with Firebase authentication, it can be integrated. And so based on whichever user is logged in, a permission can be given based on that. So this can be quite secure for you if you're if you're making a web application, you can use this for like more security. And the next thing that we have is Firebase hosting, which is obviously a hosting service that's provided by Google. Which has some built-in features that make it more secure. Like it automatically generates an SSL and TLS certificate. I'll talk to you about this in a bit, but it automatically manages providing certificates, and it encrypts the communication. These TLS basically encrypts communication between browsers and whatever like sensitive data that you're sending, it encrypts this. So Firebase automatically provides you with this encryption, and it also like mitigates DOS attacks that we talked about. So it leverages protections to make sure that your app is online even during any sort of attack. Okay. Um, okay. So, I'll talk to you about a web application firewall, which Cloud Armor that I just told you about. It is a web application firewall, and I'll talk to you about what firewalls are. So basically, they're like a security guard. So you can think of it as like a security guard for like your website where you give him the list of like these are the good guys that I want to let into my website. These are this is the kind of information that they should be carrying, and make sure that you like check that this is who I want into the website. So you give them a list. You're like, okay, uh, I want these are the guys I want to let in, and you give them a list of people that you don't want. So how does it work? So it inspects the traffic. Traffic is whoever is accessing your website. It inspects this traffic. It looks into what kind of information they're carrying and whether they're on the list of people that you trust. And if they're not, uh, and it also has like security rules. Like security rules are basically like again, you're defining what you want in your website. Like this kind of information is required. Like I need them to have their password. I need them to be required. And the other thing is you like yeah, it basically defines that, and if it filters and blocks based on that. So if you're saying that this is not there, whatever mandatory information is not there, then you can block them. Or if you're saying that this is, they're kind of okay, like they seem like they have what is required but they look suspicious, you can filter them out to do more inspection. Or if you think like, okay, fine, this guy's a good guy, he's cool, you can send them in. So like if okay, when I said that this guy's kind of suspicious, you can like, and more inspection, you can like ask them to like do a captcha test or whatever, and to make sure that they're not like a robot or something. So you can, web application firewalls help with all of that. Okay, uh, that's how they work. So now we've discussed about how we can keep our website safe, but let's talk about how information is sent across the internet, and you know what kind of protocols help us keep our data safe, and what helps us, how exactly secure protocols that we have on the internet for us. So the first thing that we have is TLS. So this is the current industry standard for communication across the web. So how TLS works is it's like a tunnel. Okay, so all of the data that's sent in to through this tunnel, it's encrypted. It is encrypted, so only your client and the client and the server that's sending it can understand. So it prevents the interception of data. It also makes sure to check that you are actually connecting to the real website and not a fake website. And this is done by using a certificate. So it makes sure that a certificate is given to the website to make sure that this is the real website. And if you're accessing a fake one, like TLS makes sure to check that this is not the right website that you're accessing. And the next thing is integrity. It makes sure that the data that you've sent is not like tampered or like changed in any sort of way. So TLS makes sure of all of these kind of things. Okay, and so HTTPS is basically it's like a secure version of HTTP, which is a communication protocol. It basically uses TLS for communication. So when you say that where a site is using HTTPS, so all of the data that is sent through the site is encrypted using TLS. Yeah, it's encrypted using TLS. So the how this works is like a browser. It retrieves the certificate, the uh, SSL certificate. It retrieves it and it establishes like a secure connection, and then the data is transferred and like encrypted and all of that, and then the session is closed. So that's what we mean when we say we're using HTTPS. And like, how do we get the certificate? So we want our website to be using HTTPS. How do we get this certificate? So how we do it, there are a lot of ways. I've given you an easy example of how we can do it, which is basically we can use this software called CertBot, which is an open source software that lets you use HTTPS on a website. By it obtains like a digital certificate from Let's Encrypt, which is a nonprofit certificate authority that gives you free SSL certificates. It's quite popular, and it gives you free SSL certificates. So when we're implementing HTTPS into our website, this is the easiest way that we can do it. So how Let's Encrypt works is it has like two web challenges that it checks for before it gives you the certificate. The first is like an HTTP challenge, which basically it lets you prove that you are the ownership. Sorry, it lets you prove that you have ownership of the website. So, and the second kind of challenge that it does is a DNS challenge, which proves that you have the domain in under your control. So, CertBot basically automates the process of this certificate, like it automates the process by like like helping you with these challenges, and it gets you your SSL certificate. I'll talk to you about proxies and web security. So a proxy is basically, when you allow someone else to do something for you. Basically, you give them the authority to perform something in your name. So, like, when you're giving attendance, you're allowing them to take your name to, like, give your attendance. That's what a proxy is. And with regards to like internet, it's basically, it helps us with managing traffic. Okay, and how it helps us manage and route whatever requests that we get is through these three things that I've listed out: load balancing, content delivery networks, and geo restrictions. So, load balancing is basically a technique that we use in computer networks to distribute the load across multiple resources. So, if you get a lot of requests, load balancing helps you make sure that you like create like multiple servers where the requests can be directed to. Okay. And a CDN is basically, let's imagine like Amazon. And if you have like Amazon has multiple warehouses in like every city, and all the popular products are like stored in each city. So like when you like order something, you can get it quite quickly, right? So because it's right there in your city. And basically CDN works in like a very similar fashion where you can have servers in a city or like in a location that's close to where your most popular requests are coming from, and data can be cached so that you can get everything working much faster. So this is quite useful when you're scaling websites, and like for big websites this is quite useful. Geo restrictions is basically just restricting who can access what based on like a geographical location. And so I'll explain to you what there are two types of proxies that we have. One is the forward proxy and one is the reverse proxy. So forward proxy, it sits over here between the client and the internet, and this internet and the servers. So it sits on the client side, on the on the client machine or whatever, and it takes requests on behalf of a client. So whatever request that you're getting, it's processed by the forward. I mean, whatever request that the client sends, it's processed by the forward proxy and on their behalf, and it is sent to the web servers. And this is useful because it like hides the client's IP address, so it provides like anonymity to the clients, and it helps in controlling access to specific websites. So if like you are not allowed to access a website, forward proxy, it helps with that. And also it caches information, which is basically it stores copies of the most frequently accessed resources, and so you can access those resources much quicker. Okay, and that's how a forward proxy works. And a reverse proxy is it acts on behalf of the servers. So, well, clients have to protect their information, but servers also need to protect their information, right? So reverse proxies, it handles clients requests. It decide like it takes in all of the requests. It decide which server uh to forward to what on based on like load balancing, and like it just like decides which server can perform what, and it sends it to the required server. And this is quite useful when we talked about DOS attacks, when a lot of people try to bombard your server with information. Reverse proxies can help with like balancing the load of each request into like multiple servers, and like so it sends the request to the server, you get your resource, it's retrieved, and it's forwarded back to the client. So this is useful again, yeah, when there are a lot of requests that you're getting, it's useful. Reverse proxies also perform SSL decryption, so it decrypts whatever traffic that you're getting, and it reduces the load on the server. It makes sure that your server doesn't have too much of like a load, and it reduces whatever load that you're getting on your server. And it basically it provides an additional layer of security by hiding whatever the internal architecture of your server. It hides that, and it provides you an additional layer of security for your server. I'll talk to you about one of the most popular um, reverse proxies that we have, which is called traffic. And I'll just show you an example of the code to show you. Yeah. So over here, we have like a traffic code that we've written, and I'll just explain to you line by line. So an entry point is basically uh, how are you entering into, like, what is the website, like, what is the port that you're entering into? So web, which is HTTP. HTTP has the port of 80. So you're entering in with an HTTP, and all HTTP requests are redirected to web secure, which is HTTPS. So you're redirecting all of your all everything that's coming in through HTTP, you're redirecting it to HTTPS, which has a port number of 443, which is the default port for HTTPS. And so this is a certificate resolver, and Let's Encrypt, which is a certificate authority, which gives you SSL certificates. So over here, you're giving your email and your storage and whatever. And this is you're saying that we're using an HTTP challenge to get my certificate. And this is all done through like certbot, and you don't have to do anything. You just have to put this into your thing, and it's done automatically. And routers are basically telling you where are you routing your requests, where are you sending your requests, and the host that we have is like your website name. This is basically your website name, and we're allowing only people who have a secure website into our website. Okay, and this is services, and so we're saying our TLS certificate is coming through Let's Encrypt, and so this is load balancing, which again, you can tell how many servers, what are the servers that you have in your reverse proxy. It helps with managing your servers and everything like that. And yeah, this is your provider, which is basically traffic is providing, and you're watching whatever traffic that you're getting into your website. So we've talked a lot about security today, and I'll try to sum it up for you. Uh, so first, we talked about what are the kind of attacks that we're facing, and we talked basically the injections. And one of the most important things that we have to do when we're like writing our backend is making sure that we validate our input. We're making sure that whatever input that we get is taken as data, and it is not taken and um, we're not allowing people to manipulate whatever they're sending into us, and we have to stay one step ahead of them. Another thing that we're doing is making sure that like we set up correct protocols for our communication. We need to make sure that all of our data is encrypted. Even when we're storing data, we make sure that it's encrypted, and when we're sending data as well, we make sure that all of it is properly secured. And we talked about how we can use Google's security features for we can how we can use Firebase for authentication, Firebase for making databases and all of that. And we talked about proxies, which are useful when we're trying to scale our website to bigger things. It helps us with watching traffic and providing like a layer of security for us and for our servers. And we've talked about how we can prevent like attacks such as DOS and everything, where we're like uh, a lot of requests are sent, and we can balance this by using reverse proxies to send it to a correct server and all of that kind of thing. And that's just it from my side. If you guys have any questions regarding this, do let me know, and I will answer them for you. Okay, guys, if we have no questions, then I'd like to end the session. Thank you very much. I had a lot of fun today giving you this session, and I hope you guys learned something from this. And yep, thank you.